All right, so that last problem was kind of complicated. It involved us computing the probability for 6 conjunctions and then computing the probability for the disjunct of all those 6 conjunctions. So sometimes the negation rule can help us out and make a problem easier. So let's go through that same problem, but look at the negation rule as a way to solve that problem. So again, we're going to roll a single fair die once, then roll it again, and we want to calculate the probability of rolling one of the following outcomes. I roll a 6 first, then I roll a 1, a 6 first, then a 2, a 6 first, then a 3, or a 6 first, then a 4, or a 6 first, then a 5, or a 6 first, then a 6. So I've got those 2 rolls, and then I've got those 6 different possible conjuncts. And my probability for the event is going to be the disjunction of those 6 different conjuncts. So that's a lot of math. However, if I stop here and I notice that that first roll always has to be a 6, and that if I get a 6, no matter what I roll in the second, I get a favorable outcome, then I can think about using the negation rule. Right? So in order to get a favorable outcome, I have to roll a 6 on that first die. So I can then figure out the probability of getting a favorable outcome by calculating the probability of not rolling a 6 and subtracting it from 1 using that negation rule. So the probability of rolling one of those pairs is going to equal 1, the probability of rolling something, minus the probability of rolling something besides a 6 on that first roll. Now, the probability of rolling some other number on that first roll is 5 over 6. And so 1 minus the probability of not rolling a 6 on that first roll is 1/6, which is in fact the probability of rolling one of those 6 different conjuncts. Finally, let's take a look at our Bayes theorem problems. So in our Bayes theorem problems, what you need to do is identify that the problem starts off with an initial probability. You get a new bit of information, and you're trying to figure out what the probability should be in light of that new information. And in practice, what you're going to want to do is to be able to identify the values for each of the variables in that equation that's given to you on the test, and then plug the values in the appropriate places. If you set up the equation correctly with all the values in the correct places, then I won't even require that you solve it to get full credit. So here's our problem. Susan runs on the track team. She must be tested for performance-enhancing drugs each season. The track organization determines that 3% of athletes use performance-enhancing drugs. The test has a 98% reliability detecting performance-enhancing drugs. That is, when it gives a positive answer, it's right 98% of the time. The test comes back positive. What are the odds of Susan using a performance-enhancing drug? So we need to start first by going through and identifying the variables for the formula. So we're trying to figure out what the probability is that Susan's using a performance-enhancing drug. We have an initial estimate. That is the estimate for just any average athlete on given the track organization's data. So 0.03. So the probability of Susan using a performance-enhancing drug, or PA1, is going to be 0.03. How do I get the probability that she's not? Well, she either is using it or she isn't using it. Or she's using a performance-enhancing drug or she's not using a performance-enhancing drug. So all I have to do to get a 2 is use the negation rule. 1 minus 0.03 is 0.97. and that's the probability before the test that she's not using a performance-enhancing drug. Next, I need to get the probability of getting a positive test given that you've taken a performance-enhancing drug. And that's given to me here. The test has a 98% reliability in detecting performance-enhancing drugs. So when it's positive, it's right 98% of the time. So that's 0.98. What about the probability of a positive test when you're not? Well, that would be the 0.02, the remaining amount below 1. That would be the probability that you get a positive test when you're not using a performance-enhancing drug. So 2 times out of 100, you get a false positive. 98 times out of 100, that positive is correct. So now, all you have to do is plug those numbers in to that basic Bayes theorem. And that theorem is given to you on the test. You don't have to memorize it. It's right there. So you start off with your Bayes theorem, and then you just plug those numbers in. So 0.03, the initial probability of using performance-enhancing drugs. 0.98, the probability of getting a positive test if you use performance-enhancing drugs. Then, on the bottom, we've got that same combination, and then the probability of not using performance-enhancing drugs, but still getting a positive test. Now, if you set the problem up like this, that's fine. I won't require you to calculate it all out, but you can calculate it out fairly easily. So you get 0.0294 over 0.0294 plus 0.0194, or 0.0294 divided by 0.0488, or 0.6 as the probability that Susan's using performance-enhancing drugs given that positive test that you just got.